Hey, good morning, good afternoon, and good evening to all. I am Venkata Appalapuram. I have 23 years of experience delivering projects in various domains healthcare, finance, oil and gas. Worked in AWS and Azure cloud environments and have extensive experience in big data frameworks like Hadoop, Spark, Kafka, etc. Today, I would like to share with you the experiences I have gone through in developing cross language libraries. We will traverse through the architectural patterns and methodologies followed while creating the Spark JMS connector project and their application to the Rust ecosystem development. Let's go to the agenda and see what are all the topics which are covered as part of this presentation. So first we will cover the project background. We'll see what is the need of the Spark JMS connector, what are all the goals and challenges we have faced while developing this Spark JMS connector. Then we will traverse through the common design challenges which we face while developing a translate language library. Number three, we will see the abstractions and the interfaces of both the JVM provided interfaces and the Rust tray. And we will navigate to the error handling strategies where we will see the JVM's patterns and the Rust result-based approach. After that, we will see how we have covered the implementation with the comprehensive testing across all the implementations, both with the Rust and the JVM. And last, we will see how we have generated the intuitive and discoverable interfaces with the documentation API design. We'll quickly go through the project background. Yeah, Capital One Spark JMS connector is created because the source is a message queue and we have different message sources with different types of message queues. You can see some JMS providers provide the message in ActiveMQ, some providing IBMMQ, and some providing SOLAS. Number two, this JMS connector should support the real-time processing because we are going to read the financial data and we need to quickly respond to the end customer as soon as we receive the financial transaction from him. Number three, this has to be the enterprise data connector for Apache Spark because we are going to reuse this connector library across all the departments in the capital. Next, the importance of it is it has to be critical and real-time data pipelines, and it has to be part of the fraud detection. And last but the greatest, it has to be performance sensitive with strict reliability requirements. You cannot lose the data. Customer gets annoyed with if you lose the data. The other challenge which we have seen is the input library. The inputs which we are getting for this library have different message patterns. We need to combine all these message patterns and make one unique message schema and handle it to different broker for implementation. With this, we have covered the departmental goals and the challenges which we are going to face by developing this library. Next, we will go to the universal design challenges while creating a library. A library always should have abstraction boundaries because the implementation may change and you cannot expect the user of this library to change his code because your implementation has changed. So there should be an abstraction between your implementation and the customer implementation. We need to create the interfaces to hide the implementation details for providing flexibility. Number two, configuration management. You need to be able to configure the things and customize the behavior of the library you should be able to enable or disable some of the features based on the configurations. Number three, error propagation. Error propagation, you should be able to communicate your failures effectively and also you need to preserve the context and the recovery options. And extensibility. You should always leave the space for the future enhancements, but you should not be that future enhancement should not come at the cost of breaking the backward compatibility. Performance constraints. You should minimize the overhead while maintaining the safety and the correctness guarantees. First pattern we have identified is the provider pattern. The provider interface pattern we used in the JMS connector fortunately has a natural analog in the Rust tray system. So we were able to easily blend the JVM provider interface with the Rust trait system, as Rust trait provides the zero cost abstractions with the compile time polymorphism. And the JVM side provider interfaces, what we have done is we have implemented the dependency injection pattern to swap the implementations based on the user selection. Now, the next architectural pattern is separation of concepts. We need to isolate the component. We need component isolation patterns to transfer between the two ecosystems so that those two ecosystems are cohesively connected. From the JVM implementation, what we have done is we have isolated the message consumers from the connection management. Message consumers don't know from where the message came from and from which message queue from the message came from. In the same way, acknowledgement strategies are also separated from the message processing. So message processing doesn't know how to acknowledge. It is separated between the connection and the processing. Connection takes care of the acknowledgement and message processing does the processing work only. Number 3, error handlers are decoupled from the core business logic. So they are used as a plug and play. The error handlers can be added or removed based on the requirement. Configuration validation, we have separated it from the usage. Now, from the Rust side, there are built-in things, module system which naturally enforces the boundaries, and there is a ownership model which clarifies the responsibility for the resources. And as I said earlier, trait objects for runtime polymorphism when needed, and we did the type parameter checking for the compile time. Plus, borrow checker also enforces the clean separation, prevents the leaky abstractions if there are. Now, let's come to the error handling strategies. So, what we need to have a separate approaches for both Rust transition and the JVM. For the JVM approach, what we have done is, as it is an object-oriented and relies on hierarchy inheritance, we wanted to follow the same. So what we have done is, we have created checked and unchecked exception throws and catches everywhere for the errors to propagate. Okay? And we emphasize for every exception thrown, we emphasized on the detailed messages and the stack tracer. We'll be able to identify the exact location of the issue and fix it. And also, while creating the exceptions and catching the exceptions, we didn't compromise on the performance. We considered the implications of the performance because of the exception throwing and catching. Now, from the Rust translation point of view, we use the result which encodes whether it is a success or failure forcing the compile time. We use the custom error enums for cohesive compile and composable error types. And for contextual chaining, we used library anyhow and this error to provide ergonomic context addition. And for pattern matching, we have exhaustive pattern match statement to ensure all the error cases are handled. Now, let's go to the comprehensive testing methodologies, where we will discuss what are the unit testing strategies and integrations testing strategies and property-based testing strategies, which we have implemented to cover the test cases. So, for JVM, we used Mockito for the interface mocking, and for Rust, we have used the mock implementations of the traits. And for integration testing, we have used test containers for the broker instances in JVM. In case of Rust, we have used container-based testing for feature flags. And in case of property-based testing, we have used quick theories or JQuick for JVM. And for Rust, we have used prop test or quick check. Now, let's move on to the configuration management patterns. Like first thing is JVM configuration approach. We have used builder pattern of the sensible defaults with the sensible defaults, and we have used immutable configuration objects, and we validated at the construction time and the hierarchical configuration with the overrides. So if you see this actually, so we have used the builder pattern for the sensible default for the JVM configurations. Rust translation, again, like in the Rust case, we have used the builder pattern with the default trait. It goes to the default trait if it doesn't find any implementation in case of builder pattern. We use a type safe configuration with the compile time validation, and for static configurations, we used constant generics, and we used config structs with the validation functions. Both these approaches emphasize the type safety and validation before use, but the advantage of Rust over the JVM is it can push more validation to the compile time. Yeah. Next, let's go to the performance considerations. So, what we have achieved after the different optimization approaches that achieved similar goals, when we have taken care of batch processing in JVM optimization, connection pooling and reuse instead of creating the connections every time to reduce the pressure on GC, and the careful memory management to reduce careful and reuse of the memory management to reduce the GC pressure, and Git friendly code patterns we have used to reduce the memory. And from the Rust optimization, what we have used is we used monomorphization, where it is zero cost abstractions. We used explicit memory management with the lifetimes, and we used compile time evaluation when possible, and we used ownership model, which achieved the fearless concurrency. Now, with this, we have achieved the performance improvement of 10 times and with zero runtime overhead, and we have achieved 99.9% of the reliability target. Now, let's move on to the documentation and API design. We have used a language, first of all, like during the coding, we have used the consistent naming conventions. For example, for JVM, we used camel case for Java variables and snake case for Rust variables. And we have established a clear domain-specific terminology that remains consistent throughout the API. We made simple use cases. We broke the complex use cases into a simple use case so that it will be easy to implement. Advanced features are available, but they are not required for the basic usage. So both the ecosystems benefit from the tied APIs with increased complexity. We have used both Rustdoc and JavaDoc to support the embedded examples. Our JVM connector provided example classes for the users to use it instead of document. It's worked better than the documentation part. And Rust documentation also, we have used the doc tests that are automatically verified. Yeah, we have explicitly documented the errors which you can throw, and what are the errors which will be thrown by the library, and what are the recovery strategies in Rust. That means we have documented all the error variants that can be returned from each functions. What are the key learnings from this library implementation? The first thing is abstraction principles are universal for all the languages. Good interface design transcends the languages. We can identify the right abstraction boundaries regardless of the language implementation. Number two, you leverage the strengths of each language. Rust's ownership model and trade system provides the compile time guarantees that required runtime check in the JVM languages. One of the things. And testing is language agnostic. You have that the test cases might be language dependent. Test case implementation might be language dependent, but the testing strategies and that are like work well between the ecosystems. The implementation details are different, as I said. And when we are implementing, and the document intent, not just implementation, while we are implementing the code, we have explained why a design choice is made. It is as important for the documentation and how to use an API. So that while generating the document, you will get all the information on how to use the API and what design choices you have made, regardless of the language. Yeah, thank you.